Earthquakes can strike anywhere in the world, at any time. When they do, they may result in considerable damage, not only to structures, but also to their contents, and cause injury or death to the people working inside. To reduce or in some cases eliminate this damage, many builders and building codes call for the use of seismic isolation. It works by decoupling the structure or equipment from the ground so that when the earth moves during a seismic event, the building and its contents are largely unaffected. Dynamic Isolation Systems is the world leader in seismic isolation, having completed over 400 seismic isolation projects, designing and supplying nearly 20,000 isolators to 18 countries over the past 30 years. No company in the world has more completed isolation projects in more countries than Dynamic Isolation Systems. A simple shake table demonstration clearly shows how the contents of a non-isolated structure are displaced by ground motions. By contrast, the same structure, now isolated, experiences far lower acceleration and experiences much less damage. One method of achieving seismic isolation is through the use of lead rubber bearings, or LRBs. Lead rubber bearings are comprised of alternating layers of rubber and steel around a lead core. The rubber and steel provide high axial stiffness combined with low lateral stiffness, while the lead core provides energy dissipation to absorb seismic motions. LRBs are typically installed under each column of a building or on the top of piers and bridge applications. Isolators may be used in either new construction or retrofitted into existing structures. Numerous prominent historic buildings have been retrofitted with DIS isolators, including the Utah State Capitol building in the United States. This building is now protected with 273 LRBs, some as large as 1,100 millimeters in diameter and weighing up to 3 tons each. In New Zealand, over 400 isolators were used to protect the Parliament House and Parliament Library in Wellington. Hospitals are excellent seismic isolation candidates. An isolated hospital will be operational immediately following an earthquake because its contents will be undamaged. This may prove critical to saving lives. The Xindian Hospital in Taiwan at 1.3 million square feet is one of the largest isolated buildings in the world. The Tanzhou Hospital, also in Taiwan, is even larger at 1.7 million square feet. Both are protected with isolators designed and supplied by Dynamic Isolation Systems. In a prototype test for the Xindian Hospital, a 1.3 meter diameter bearing is displaced to 1 meter while supporting a load of 2,000 tons. The extreme performance of this bearing is achieved using advanced rubber formulations developed by DIS and through the incorporation of molding and processing techniques not normally used by the general rubber industry. Emergency centers and fire stations are also popular candidates for base isolation, as they need to be fully operational following an earthquake to enable emergency management efforts to commence immediately. The Berkeley Public Safety Building in California, protected by DIS isolators, will allow city, state, and federal agencies to coordinate from a single location following a seismic event. In response to a growing demand from tenants who wish to live in safer, high-performance structures, condominiums are now often protected with seismic isolation. Buildings that generate high revenue or that accommodate essential equipment require better protection than that provided by conventional design. Museums that house not only valuable but irreplaceable artifacts also deserve the utmost preservation that can be engineered. In California, the Asian Art Museum's $7 billion collection is protected with 200 DIS base isolators. Bridges benefit from this technology as well. In addition to seismic protection, isolation also resulted in cost savings for the JFK Light Rail project in the eastern United States. Base isolation reduced ground forces, enabling the designers to use smaller foundations and footings, which saved money. Furthermore, the smaller foundations eliminated the need to relocate underground services and utilities, providing even greater cost savings. The Coronado Bridge in San Diego, California crosses over a major earthquake fault line. The incorporation of viscous dampers and seismic isolators will enable the bridge to withstand a major rupture in that fault, should it occur. Testing of the bridge's isolators was conducted at the University of California, San Diego on a test machine built by Caltrans. This test rig allows full-size bridge-bearing tests in real time, precisely replicating the conditions expected during an actual earthquake. This lead rubber bearing is 1,000 millimeters in diameter and has a 280 millimeter diameter lead core. Each cycle of testing is 2 seconds in duration. This test machine has proven to be a real asset to the engineering community. It has enabled us to better understand the performance of structures and seismic devices under real earthquake conditions. For more information about base isolation or any dynamic isolation system seismic protection solution, call us at 775-359-3333. Email us or visit our website.